Welcome to another podcast. In this episode, we're going to be taking a look at how to calculate areas under the normal curve. Now, we're not going to be relying on the empirical rule to do this because these values are not going to fall on specific standard deviation markers. In order to do this, I thought it would be nice if we took a look at a real set of data. And so what I have here are scores of the people that took the SAT in June 2012. So this is the June 2012 data for the SAT, the number of test takers, and it has their scores for critical reading, mathematics, and writing, sort of parsed out according to both mean and standard deviation. So let's look at this first question. I have three questions here I want to look at with you. Each of them represents one of three possible types of questions you could be asked. So what percentage of students score between 650 and 750? You should start most of these questions by trying to draw an accurate picture. For this one, between 650 and 750, we are on the critical reading scale. So the mean of this scale is at 496 and the standard deviation is 114. Now remember, these are population numbers, so this is mu and sigma. So looking at critical reading, what we're asked is what percentage score between 650 and 750. So I'll just indicate the region that we're looking at, 650 to 750. Now this is not drawn to scale. I'm just trying to give myself enough room to describe where the data is. And so we're looking at this piece in here. And what we would like to find is if you were to select someone at random from this group of 1,664,479 test takers, what is the probability that their score will be between 650 and 750. That's what we're trying to calculate here. And that probability is the percentage of area under the curve between 650 and 750. Now, in order to do this, I'm going to bring in the desktop version of Math Studio. And the best way to handle this particular problem is by using what's called the normal CDF command. Now, in the options, or excuse me, in the catalog, I'm just going to search for normal CDF. If you have the iPad version, you can just scroll down to find it. But this is the command that we would like to use. Do not use normal PDF. We'd like to use the normal CDF command. So I'm just go ahead and click that. And the normal CDF command takes 4 arguments. You need to tell me what the lower bound is, what the upper bound is, what the mean is, and what the standard deviation is. So for this problem, we have a lower bound of 650, an upper bound of 750. You can see our area here is bounded by those two numbers. We have a mean of 496 and a standard deviation of 114. If I hit solve, this will return the area to me. So we're looking at 0.0754, let's say. All right, so this probability is 0.0754 or 7.54% of people score between 650 and 750 on this particular iteration of the test. All right, let's turn our attention to this next question. What percentage of students score above 800? So based on the data, we are looking at the mathematics distribution in this case. So I'm just going to draw in sort of a normal curve here. That one's not the best looking. Let me try again. So I'll draw in a normal curve. And the center or the mean of that curve, we're looking at mathematics now, has a mean of 514, a standard deviation of 117, and I'm looking for those students that scored above an 800. So what I'm after is the area in red given by the tail of the distribution corresponding to the question being what is the probability someone randomly selected scores greater than or equal to 800 on the math portion. Now I'm trying to find the percentage of area under that curve, and this would be a little bit difficult. Let's talk about the normal CDF command, and then we'll bring it up here in a second. Remember, the normal CDF uses the the low value first, uses the lower bound, uses the upper bound, uses the mean, and the standard deviation. Here's the problem. It's clear that the lower bound of the red region is 800. The problem is we don't really know what the upper bound is. Technically it's infinity, but we're not going to ask the calculator to put infinity in for one of its answers. And so instead what I would propose we do is the following. I'm going to try and find the area in blue first. And the reason that I'm going to try to do that is if we can find the area in blue, then we know the area to the right of 514 is 0.5. And so if I take 0.5 minus the blue, I should get the red. So let me write out what I'm going to do. If I'm trying to find the area for the red, that is 50% of the area, 0.5, minus the area in blue. And the area in blue should be found by looking at the normal CDF of the lower bound, which is 514 for the blue, the upper bound, which is 800, and then the mean of 514 and a standard deviation of 117. So this is what we're going to enter into our calculator for this problem. And so we've calculated that to be a very small percentage of people, 0.00725. So 0.00725, which is approximately 2 decimal places here, 0.725%. So less than 1% of people score 800 or above. We know that 800 is the maximum score anyway, so this is looking at approximately what percentage of people score exactly 800. The greater than 800 doesn't really apply here, but it's saying about 1% of people that take the test, in fact less than 1% of people take the test, make the maximum value on the mathematics portion. Alright, so what percentage of students score below 200 in writing this time? We're going to be looking at a different distribution here. Just give me a normal curve I'm going to draw in. So we're looking at writing. And writing has a mean of 488 and a standard deviation of 114. So looking at writing right here. Alright, I want to know those students who score, or what percentage of students would score below 200. So I'm looking for the other tail here, the area in red. And this will be done very similarly to the one we just got through looking at. Instead, I want to find the area in blue. And for this particular example, the area in blue, I propose to find the area in red by taking 0.5, which is the entire left-hand side, that's blue plus red, and then I'm going to subtract off the blue. And the blue will be the normal CDF from 200 to 488, with a mean of 488 and a standard deviation of 114. So this is how we're going to calculate the probability that someone scores less than or equal to 200 on the writing portion of the test. So bring in the calculator one more time here. And so we calculated that value. It's also a very, very small percentage chance at 0.0057. 6, so that's 0.00576, which is approximately 0.576%. So less than a 1% chance of scoring below 200, less than a 1% chance of scoring above 800 on the math, and about a 7% chance of scoring between 650 and 750. So these are the three possible types of questions we can ask for area under a normal curve. I can ask you for the area between two values, as we did in example 1. I can ask you for the area above a value, as I did in example 2. Or I can ask you for the area below a value, as I did in example 3. So just make sure that you understand the different components of this normal CDF function, because that's what you're going to be using when these values do not fall on one of the standard deviation markers. All right, thank you for watching.